Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Theodore from Business Review, and I will be your host. It's our pleasure to have Coldjet with us today. We'll be presenting this webinar entitled Dry Ice 101, Food Processing and Last Mile Cold Chain. Today's guest speakers are Rick Torres and Ben Shepard, who are Directors of Sales to Coldjet LLC. Before we begin, I would like to welcome you to our webinar platform on 24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you have received via email to rejoin the session. In order to ask questions, you can send them in via the questions widget. Just type them into the box and click submit. We will allocate some time at the end of the session to address any questions or thoughts that you might have. Please use the yellow help widget if you require any assistance, and you can move, resize, or maximize any of the windows in front of you to get a better view of the slides. But now, please allow me to welcome Rick.
Good morning. Again, my name is Rick Torres. I'm the Director of Sales with Coldjet, working in the food and beverage sector. My job with Coldjet is to help bring value to our customers by coaching them through the process of incorporating Coldjet technology into their food processing in order to bring value to them in cost savings on CO2, to help them improve safety, to help them improve temperature control and processing, and in many cases to help them achieve their ESG goals as well.
Hello, and I'm Ben Shepard. Many years working with dry ice, solely focused now on the home food delivery cold chain arena, and looking forward to answering questions and going through the process of making dry ice today.
So let's review our agenda really quickly. As we go through this presentation, Ben and I are going to kind of touch on 6 subsections of what we want to talk about. Initially, number 1, we're going to cover dry ice, what it is, how it's made, how it's used. We'll touch on food processing applications and how dry ice is used in that. We'll talk on food delivery applications and again, how dry ice is incorporated into that and some of the recommended formats that we have for you. We'll discuss dry ice versus other cooling alternatives, the benefits of using dry ice, and we'll talk about some of the other options that you have and why we think dry ice is the superior option. The question, should you make your own dry ice? There's a lot of variables to consider when you want to decide to make dry ice in-house. We'll cover some of those variables and help you walk through that decision. And lastly, infrastructure needs, what you need from a storage tank to piping to our technology and how it all incorporates together and what you need to do to get there.
So the big question is, what is dry ice? Dry ice is solid CO2, and CO2, as we all know, is a naturally occurring compound, not an element. And lots of things about dry ice that make it very fantastic for last mile. All dry ice is minus 109 or about minus 78 C. It does sublimate. The word sublimation, there is no evaporation, there is no liquid, there is no water. It's just solid CO2. So as it goes directly from a solid to a gas, there's no residual media left over. And it is safe around food. So that's why we're talking about it again today. Most CO2 or most dry ice these days is made from recycled CO2, CO2 being sourced from industrial processes and reclaimed. Sun dry ice CO2 is sourced from some wells, and Rick will be talking about that momentarily.
All right, where does CO2 come from? So in the process, in order to make dry ice, we originally need to start from the front end with CO2 raw. So where does that come from? Typically, the 2 major processors right now are ethanol plants and ammonia plants. They produce raw crude CO2 for further refining to get to the merchant market. Based on current information, ethanol plants probably produce about 35% of that. In the fermentation process of corn, to make the ethanol, a byproduct of that is pretty pure CO2. Ammonia plants, again, make about 25%, and that is due to the process to make ammonia. The nitrogen fertilizer is in high demand across the world, and so that keeps growing, which gives us more raw CO2 as a feedstock. Hydrogen plants in their process, a byproduct of CO2. Some naturally occurring wells also produce CO2 in the United States, which we draw from in cogeneration. So those are typically the sources of where raw feedstock CO2 comes from. So this is kind of the process chain. If you look at this slide here, starting on the left with number one, that would be one of the processes that I initially discussed, whether it was ethanol or an ammonia plant or hydrogen processing. So if you look at that, they'll produce a feedstock of CO2. You can kind of combine pictures 2 and 3 together, and that would be a processor that sells to the merchant market, and usually a major processor, whether it's Messer or Linde or Air Products or one of those. They will take that feedstock, they'll refine it, they will purify it, they will condense it, and they will put it in a form where they will store it on their facility, and then they can transfer it to number 4 into a transport truck. This truck typically holds about 20 tons of product, and it will transport, once you sign a CO2 agreement to be supplied, it will transport it to your facility where it will be stored in a liquid CO2 vessel, and then it will be piped into your building to the dry ice machine where you'll make dry ice. Some technology that we also have on the far end of that is CO2 recovery, where we actually have technology that will take the exhaust off of our machine, recirculate it, recondense it, and put it back into pelletizer for reuse, so that you're further using CO2 and be much more efficient in your process. So next is a video that's going to show one of our pelletizers. This is our PR750H pelletizer in operation. So this pelletizer is designed to output about 1,650 pounds per hour of dry ice. As you can see, it has 2 output chutes, and typically in your process, it would output dry ice into a tote that can be moved around your facility for operation.
So what's happening inside that pelletizer is we're injecting liquid CO2 in there. It's immediately phase changing to both a solid and a gas. And then we're having a piston push it through a die plate, extruding it out the front of the system as you see here now.
These die plates come in various sizes, anywhere from 3 millimeter up to 16 millimeter nuggets. So depending on what your operation requires, we can help set you up with the proper die size. On the left is 3 millimeter nuggets, and on the right were bigger 16 millimeter pellets. Okay, let's talk about a little bit about dry ice and food processing applications. So dry ice is frequently used in the protein sector quite a bit. Whether you're a beef processor, poultry, pork, seafood, it's used to maintain temperature and to inhibit microbial growth. In the bakery sector, it's used to maintain consistency of batches and maintain temperature of the batches. And then in the beverage sector for wine processing, it's used to maintain fermentation. So Q10 value is basically a temperature coefficient which measures a product's ability to interact and have a chemical change, which would result in microbial growth. And so the Q10 value for most foods is 2, which basically states that for every rise or decrease in temperature of 10 degrees C, you are 2 times more likely, you double the ability for microbial growth if that temperature increases by 10 C or decreases it by 10 C. So this is why it's very important for a food processor to maintain temperature, and the ability to maintain it with dry ice is one of the most effective ways to do that. So in the protein sector, again, dry ice is used throughout many facilities, many fabs around the world in reducing spoilage, reducing microbial growth, and inhibiting bacteria growth. Again, for large-scale bakeries, dry ice can be used as opposed to water ice. It's much more efficient for maintaining fermentation, for keeping yeast cool. And one of the big advantages of using dry ice is you can maintain batch consistency. So every batch comes out the same and your product is the same. And then again, in the wine sector, dry ice a lot of time will be placed on top of a tank in order to maintain temperature, to inhibit oxidation and oxygen entraining into the product, as well as kind of controlling the fermentation process. So if you're filling a tank and you want to slow down the fermentation process, you can add dry ice to the top of that. So which is the best medium for dry ice? We can coach you through this depending on what your process is. We have a lot of experience with different facilities to know what they use in the different industries. You can start with 3mm pellets up to 60mm nuggets, or dry slices, depending if that's your need, and we can help you and design the equipment that best fits your operation.
So there's a lot of applications for dry ice in home food delivery, and we're seeing continued growth in this arena where we're using both dry ice nuggets, typically the 16mm nuggets, or 5-pound slices. So typical fulfillment box, keeping proteins cold, ice cream, confectionaries, various things, juices. So again, temperature control during your cold chain operation. We have customers that are shipping product all over the world, so we may have 5- and 6-day points sometimes. So a lot of pick lines, home fulfillment, food fulfillment, shipping with various forms of dry ice, being it slices or nuggets. The choice between slices and nuggets is something that we typically will consult with you to see what works best for you. Most of the people we talk to are already using dry ice in one form or another. So that discussion comes into why are you using that form, nuggets or slices, and we can come and coach with you to see what is the best form, what makes the best sense for the equipment, what works for your pick line. So again, nuggets and slices are typically for home food delivery. We are typically always bagging the dry ice nuggets and slices. There's a couple of reasons here. CO2, as it sublimates back into a gas, creates a blanket of CO2 around the dry ice. And this inhibits or slows down the sublimation process. And also when it hits the end-use customer, they don't have to put their hands and touch dry ice. They just have a bag that they can pick up and remove from the box. I think this is the video here. Maybe we'll click one more time. Shift over here. This is a slice line here. We'll come back to this in a little bit about how the equipment works. We have some automation options. So sometimes we're loading in ice bins. Sometimes this is a bagging operation. So sometimes these bags are going directly into fulfillment boxes. Sometimes we're just hand picking it in. So dry ice versus refrigerated transportation. Lots of advantages in dry ice. Number one, it's a one-way solution. You're not having residual boxes that have to go back and forth. You don't have electric refrigeration. There's less fuel used. Gel packs, you have a waste item. A lot of customers these days are a lot of pushback for landfill.
All right, so dry ice versus water ice. A lot of benefit using dry ice over water ice. When you use water ice, you typically will have, once the ice melts, you'll have residual water at the bottom of your box, which can cause microbial growth. It also adds extra weight. When dry ice sublimes, you lose that weight in the shipping or in your tote, whatever you're using. So dry ice is really preferred over water ice. And you also don't have to have the facility to dispose of the water that's left over from water ice. Dry ice versus an active container. Most active containers are operated by batteries. So if you have a battery failure or it just goes dead over time, you lose your refrigeration capacity. We can size dry ice to get in your package to get to where it needs to be so that you have just a little bit of dry ice left and you're using it in the most efficient manner and you're not risking losing your refrigeration capacity. Dry ice versus snow horns. So in many protein processors, they use snow horns to make CO2 snow, which is then shoveled over product to keep it cold, maintain temperature. And we've had a lot of success removing snow horns and putting in place of those dry ice pelletizers. Our pelletizers are very efficient and they use about 50% less liquid CO2 than a snow horn does. You're also not having to order a other equipment, and you can make it on demand. So you can make it the night before, the morning of that process, and use it where you need. And the refrigeration capacity of dense dry ice is higher than CO2 snow, so you'll use less dry ice over time.
So often the question about dry ice, should I make my own? Should I buy it on the open market? Should I make my own? There's cases for both sides. Volume has a large play in it, but also just-in-time production can have an equal weight to that. And then sometimes there's a huge labor savings of handling of the dry ice bins. There's a volumetric space of all those dry ice bins on site. So a lot of factors go into should I make my own dry ice, and this is something that we work with our customers to determine what's the actual cost of making your own dry ice on site, what are the advantages of my pore space, what's the infrastructure need. We go through this whole process, and it becomes very black and white if it makes sense or not. So yeah, so I'll go through all this real quick here. So there's lots of options when you're dealing with dry ice. If you have dry ice sourced from the open market, you're typically purchasing in pellets, nuggets, slices, bag nuggets, and it gives you lots of options on how to do that. So there's lots of types of equipment that we have. This is just a couple representations. So I'm making bulk dry ice into a bin, or making slices and automatically depositing them directly into a box. Again, here we have bag nuggets. Very straightforward again. This is the pelletizer on the bottom here, and then this is the system that's putting the dry ice into a bag. Slice equipment here, we have again the dry ice production equipment feeding into what's called a reforming system that's taking a high density dry ice pellet and then forming it into typically a 5-pound slice, running it through a bag system, and then in this case here being loaded into a cargo bin on site. So this again allows you to do two things. A pick line can be right next to the production line, or we can be feeding dry ice into a bin and making it for later day usage, because typically in home food delivery, the heavy days are Monday, then Tuesday, trailing off Wednesday, Thursday, often no deliveries on Friday. So, but we may have such a high demand on Monday that we want to make stock weekend before the actual Monday. Again, we have the ability to dose the dry ice directly into a fulfillment box.
All right, let's talk a little bit about infrastructure required for a dry ice production system at your facility. There's several components you can see. This kind of depicts the process. A liquid CO2 truck is on your site. It's filling your liquid CO2 cryogenic tank. The green line is piped into your pelletizer, and you're making dry ice. I'll go through each component and talk a little bit about it and give you some information on it. So the first piece of equipment you're going to need if you don't already have dry ice or don't have liquid CO2 on site is a CO2 tank. This is going to include the tank itself, and one of the components for that is going to be an engineered foundation for that tank. And all these things that I'm going to go through, we can help coach you through this process. So when we work with customers who don't have liquid CO2 on site, we work with them with different vendors to get them through the process as easily as possible. As I go through these, we'll have a little video showing you some of those components. So this is the video. These are very large tanks. You won't always need a tank this size. This is for a very large operation, but that gives you an idea of what a liquid CO2 tank looks like. So once you have the CO2 tank in place, the next component you're going to need is piping. You're going to need to pipe the liquid CO2 into the pelletizer. And typically you want to have your tank as close to the pelletizer as possible. We can work with you on those designs. And then also you're going to want to decide what type of piping do you want. Do you want copper pipe? Do you want vacuum jacketed pipe? Do you want a combination of both? Depending on what your supply is. So we can help coach you through that piece of it. This is some pipe out on the pad going into the building. and that's what it looks like insulated, and that's the top of the pelletizer where it goes into the unit. Your next component is going to be power supply. So the pelletizer requires 480 three-phase power, and also, which is the orange line, which also requires a high pressure line, about 100 psi, in order to operate the valves. This is an idea of just some of the power units that are required. It's pretty simple, pretty straightforward. Nothing different than what you already have in your facility running your other equipment. And then the last thing to consider is ventilation. When you go through and permit your process, you're going to be required to set up ventilation. It's very simple, as well as CO2 monitoring. We can give you ideas on how to do that, and it's a pretty simple process. As you can see, it's just shutter fans that are installed and a monitor installed on the wall. And again, we can coach you through all this to make it an easy process for you to get it installed.
So what we found is that dry ice is very, very sustainable cooling method here for last mile cold chain delivery. And the fact that we're using a recycled CO2 typically, and it being an environmentally friendly product that way, and no residual media to deal with, no waste at the back end, a lot of people are switching to dry ice for their standard shipping method. Nice thing about dry ice, it's very straightforward to determine how much dry ice goes into your fulfillment box. Very long cycle times, like I said, up to 5 days sometimes, depending on how long you're delivering, how many day point you have. Lots of different forms of dry ice, slices versus nuggets. They both have their pluses and minuses. And making a dry ice, as you can see, the equipment is really straightforward and easy to operate. It can be automated, it can be manual operation. You have a lot of different ideas of which way is best. And we work with you to help to see what is the best method.
If you have any questions, feel free to put them on the screen here, and we'll be happy to answer any questions for you.
Thank you, Ben and Rick, for the great presentation. We have a few minutes now to address the questions you have been submitting. Please bear in mind, if we don't get to your question today, the question could be answered on a later date. So without further ado, the first question we can answer now is, how do I store dry ice and how long does it last?
I'll take this one. Typically, dry ice is stored in a bin, and let me see if I can go back into here and put up a picture. Let's go here. All right, is that up?
Push to audience.
All right. So this is a dry ice storage bin, and to get the longest life out of dry ice, we want to have a nice thermal bin like this, and we want to keep these bins closed. We can see, so dry ice is going to always be sublimating at 3 to 5% per day, every day. So what we want to do is keep that bin closed. And the reason is that there's CO2 gas that's covering and blanketing the other dry ice that's in there and displacing any oxygen or moisture that might get into the bin. So the idea is that have a calculation of 3 to 5% per day on a closed bin. Once you open that bin, the dry ice is going to start to sublimate quite rapidly. I don't have the exact percentage rate, but the ideal way to store dry ice is this. Putting dry ice into a freezer does not make it last longer. A freezer is just cold, and it's actually quite hot if you think of dry ice. Dry ice being is minus 109, your freezers might be minus 20. That's a big swing in temperature. So that's a consideration. I often field the question, we put the dry ice in a freezer over the weekend, we came back, it was gone. Well, typically freezers also have fans blowing air around, which again is going to speed up the sublimation process.
Another thing to consider with the bins that you store dry ice, and they typically come in 2 different sizes. These are 550-pound bins. They also come in 1,600-pound bins. So depending on the size of your operation, you can size them accordingly. Also, if you're buying dry ice and want to make dry ice at your facility, one thing to consider is that if you're buying dry ice, you're going to take your delivery and have a lot of bins sitting around. Once they get empty, they're still sitting around, taking up a lot of valuable floor space. So if you make dry ice on demand, you can really reduce the number of bins that you need.
Thank you for addressing that. Moving on to the next question we have today. How much does a dry ice production machine cost?
Good question. It's a very wide cost variance from a straight basic system of under $30,000 that's making true high density dry ice, all the way up to a multi-million-dollar system that's an automated production line. And again, it comes into volume, how many pounds an hour, how many kilos an hour do you want to make? When do you want that dry ice? You know, do you have time to make it before you need it? Is it an in situ process? So that's something, again, we work with on a common basis.
Yeah, and we'll coach you through the process. There's a lot of information that we gather in the introductory phase of working with the customer so that we make sure we size the equipment appropriately for what they're doing today and what they want to grow into, so that their capital spend up front brings as much value to them as possible. But we'll work with you through that process.
Thank you both. Next question we have. Are there safety precautions with dry ice production?
CO2 is an oxygen displacer. CO2 is non-poisonous. Carbon monoxide would be the poisonous one. Carbon dioxide is a oxygen displacer. So as we said before, we mentioned a CO2 monitor. Again, as the CO2 comes out of the system, there's a couple things to consider. First thing is the quantity of dry ice you're going to have on your floor at any given time, right? That's the first piece. Are those bins opened or closed? That's the next piece. Does the facility already have HVAC or air changes happening? That's another piece. So it's very safe to work with dry ice. The next thing considerations are, you don't really want to put your hand and touch dry ice physically. You want to be very cautious that being minus 109, it can cause a freezer burn. But the actual having dry ice production on production floors is very safe and very straightforward.
Yeah, and keep in mind, hundreds and hundreds of companies, thousands of companies use liquid CO2 and dry ice on a daily basis in their operation. It's very common. It's very user-friendly. It's safe for food applications. Like what we talked about of having ventilation and monitoring is the key to it. And another thing is to make sure that you train the employees on the safety precautions and how to use it. But it is overall, it's a very safe process.
And we have some safety precaution data that we can send out for proper handling of dry ice.
Thank you for addressing that. Next question I can see. How much LCO2 do I need to produce a pound of dry ice?
Okay, good question. Without recovery, which is where we're recycling the CO2 back into the system, we are converting liquid to solid at a ratio of 2.2 to 1. And typically liquid CO2 is sold by the ton. So a rough calculation there is you get about 909 pounds of yield from 1 ton of dry ice. However, if we use recovery, we can bring that down to anywhere between 1.1 to 1.3 pounds, depending on the type and scale of recovery system. But the general answer from most companies is it's a 2.2 to 1 conversion ratio.
Thank you. Next question is how to avoid frosting on the product.
Well, it depends on what your product is. And a lot of times just using a simple barrier on top of the product, whether it's plastic or cardboard, prevents frosting on the product. It also depends, are you trying to freeze your product or are you just trying to chill it? We can help you do testing here, and we can calculate how much dry ice is required to reach your goal of either chilling or freezing and not having frost on the product.
And again, frosting can be a factor of how much humidity is in the air. You've got a very cold product and the cold air is rushing towards the very cold dry ice. So that's a big factor too. What's the humidity level of actually the ambient room temperature or ambient room humidity, or what's inside the box?
Thank you. Moving on to the next question we have. Designing the piping for liquid CO2 transfer pipe. If we have high point in piping, should we consider vent on the liquid CO2 line?
Yeah, so liquid CO2 line has to have a vent incorporated per code between every type of shutoff valve. So depending on what your design is, you can absolutely definitely require venting on the pipe. It's a pressure vent.
Thank you. A couple of more questions we can address today. How to calculate costs of dry ice for the last mile delivery on ice cream cold chain?
Oh, okay. There's a lot of, this is a very complicated and very interesting aspect of cold chain with dry ice. And it's a little bit, something we won't go into too deep right now. However, we do have the ability to help you determine how much, if you've got X pounds or X cartons of dry ice, of ice cream, how much dry ice should go into that. But, and it also comes down to what is your shipping package going out? What's the R factor of your own shipping container? Is it sealed? Is it not sealed? And I say sealed, that's a loose term. So there's a lot of factors when we're talking about shipping ice cream or any product, but determining the proper amount of dry ice, it has to do with how many day point. Is it a 1 day point, 5 day point? Where is it going? You know, what's the temperature where it's going? What's the chance of it being delayed to where it's going? So all those are having factors of how much dry ice is going to a particular package.
Thank you. I guess that we have time for final 2 questions. What is the temperature of liquid CO2 line? Do we need to get the pipe stressed analyzed?
No, so liquid CO2 is at -109. And so whether you're using copper pipe or vacuum jacketed pipe, they're all designed easily to sustain that temperature. So you don't need any additional stress testing on the pipe. You would use K-type copper or stainless steel vacuum jacketed, which is used throughout the industry and readily available.
And we have time for one final question. Is dry ice ESG friendly?
Yes, so dry ice is recycled CO2. And as a matter of fact, in some projects that I'm working on now, we have customers who have ESG KPIs or metrics that they have to meet. And we've been able to show that by incorporating making dry ice in-house, they substantially reduce their use of liquid CO2, and they can use those numbers to reach their ESG metrics throughout their facility. So very much so, again, it's recycled, and using our equipment, you can help reduce the overall use of liquid CO2. And if you're getting CO2 delivered on a weekly basis, say you're getting 20,000 or 40,000 pounds delivered, we have the ability to calculate over time how many truckloads you're going to save. And we've had customers that use that number also to say, you know, we've taken this many trucks off the road, and each truck has a certain amount of tons of CO2 that they emit per year. And so we can calculate that, and they can use that for their ESG numbers as well. And
then in the cold chain arena, refrigeration trucks, they're using quite a bit of fuel, so that you have a carbon emission there. The backside of there's no gel pack going into a landfill. There's no product that needs to be returned back to the original fulfillment center. So it fits right into the ESG calculations and formats.
Thank you both. I guess that's all the time we have for questions today. To attendees, if your question was not answered, please again bear in mind this could happen on a later date. Thank you both for what was a great presentation, and once again to all attendees, you receive an email after this webinar that will tell you how you can access the on-demand video. We look forward to sharing further webinars with you, so please do keep an eye out on our website, www.pmi-live.com/events. Thank you once again, and I hope you all have a great day. Thank you.
Thank you.
Thank you.
Okay, so